what I basically have since called it, that makes it almost impossible to understand some of the code. So my first advice is keep it simple. When I think doing this stuff in the small or maybe medium is absolutely fantastic and worth doing. And then of course, having these backends means that you now become responsible for developing those backends, which requires special skill sets, resources, time, etc. So basically, what I'll show is just some of so this is the utopian view of what writing model code should look like. This is not actually what it looks like in VM when people get their hands on it. But this is kind of the first part here is what we see here. Getting a counter is allocating a register. And then you load that register, and then you can increment that register. And so this is all done in Smalltalk, and it's generating the assembler. It's not simulatable, but it is a generatable spec that you just kind of type it and press go, and it spits out whatever assembler you actually want. And so the next part is like a while loop. So there's the nice kind of while loop. That's kind of what you want. So you can see here, you load a counter and you can do a test on not equal. So it's a very object-oriented framework that's really actually very nice once you kind of get into it. Really hard to extend, I found, but very nice. But then you start to run into more of these kinds of things, and this is step one in the journey of obfuscation, basically. So people begin to write things like this, where you have a label and you place it somewhere, and then you do some stuff, and then you jump to a label, and you start to go down more to the assembly level. So then imagine that you have a whole thing like a VM with algorithms you're trying to understand and kind of these concepts, and people's chosen patterns are to jump around, hide things. Basically, it acts as kind of a macro assembler layer. So you're macro, calling a macro, and then all of a sudden I'm going to jump. And I'm going to jump over here right in the middle of this place, which has 5 different labels. And then I'm going to do a little bit of work, but I'm going to jump now. And I'm going to go back over here. And that's basically what it's like trying to figure out how RVM works. So, but if you can keep it simple like this, you can do really great things. And it's absolutely worth doing. I think it absolutely is. Again, takes resources to be able to do these backends. Back in the time, IBM had large teams dedicated to doing this stuff, who had those specialized skill sets, but you absolutely have to have those. Not that I'm aware of. I'm sure you could with the knowledge, but I know that our method of debugging was printf, and so that's kind of all we had access to. And like I said, it just requires a lot of skills in the area, and I think if you have those skills, it's a worthwhile endeavor. But actually, this stuff, programming in the large, it just didn't scale well. Yeah. Yeah, it is. Well, it certainly feels that way. And, oh, yes. Oh, okay. Lots of backends, but you got to maintain the backends. So it's not like, so it's kind of like you have a project in C, you need to take it someplace, but there's no C compiler for it. So now that's part of your project is to develop the backends, right? Oh, we're a lot happier. Oh, yes. Yes, I am unapologetic when it comes to what we've done. So basically, this is kind of, so this is some of the, you kind of get, if you kind of what a method-ish would look like. And so it's, again, it's nice. It's nice to be able to do if you write it well, but it leads to a whole set of design patterns when you scale this that, if you're not careful, can turn into a big, giant, sloppy mess that's just no better than doing it in different ways. And so so I guess the SH Ford thing didn't work out because the model code didn't actually load, and half the instructions that were supposed to be modeled weren't there. So when I generated it, it just blew up, and of course I had no idea what to do. So I went and found ARM. So I got ARM instead, loaded Ubuntu for ARM, and then was able to generate this rate monotonic scheduler simulator. And it did run on ARM. It ran nicely. And so I created the C representation, and then I created the model version from ARM, which, again, you keep it simple, and it would tend to look kind of like that. So in this case, we see an entry point from, so this allows C to be able to call into, using the high-level call prototype there. We say number of parameters, it's going to return data, and then you say, and so basically this is nothing more than in C, just a bunch of assignments to a struct. I mean, that's what this is turning into, and in fact, we can see create task here. It's just that, and so that's kind of the look and feel, just to give you a flavor. And I won't show the VM because I don't want to do that to you, and nor myself. So thank you very much. Appreciate your time.
Okay, do you hear me? Yeah. Thank you. I have one message or two messages for you. I want to say I do parsing, and I want to say that I do parsing that might interest you. If that's all I wanted to say today, but actually, if you want to listen a bit more, I can show you a demo if you're interested. Otherwise, you can check your Facebook and emails and etc. So far, I have implemented two things. Everything is available for Petit parser, but it can be probably somehow ported to other technologies as well. First thing is tolerant parsing, and the second thing is indentation parsing. So far, I'm doing my PhD for 2 years, and there are 2 years left. It seems I can handle one topic per year, so there are still 2 open topics. So if you're interested in some problems, you might talk to me, and maybe we will find some nice topic for my dissertation later. Regarding my demo, here is a small setup. Let's suppose you have these files like this, and it's like some kind of language. I don't know what language is it exactly, but my interest is to extract the methods from files like this. There are 3 methods. 2 methods belongs to the class, and 1 main method is like a global method, whatever. So your task is to write a parser to handle this thingy. And yeah, it's working more or less. So we can start with a method like this. Here it's prepared. I have a parser for the method because it's what's interesting for me. The rest of the things are not interesting for me. And if you write code like this and you want to parse it, Actually, I should inspect it. You get an empty array, obviously because your grammar does not correspond to this, because in the source that there are more things than a sequence of methods. There is this class, some variables, and end class, and another method. So if you're not interested in this part, but still you want to extract the methods, there is this magic keyword you can use in Petit parser. You use the method as an island. Island is something that's what I'm interested in. What's the everything else? It's not important for me. So have a look what happens now. Okay, and now I extracted 3 methods. So what does it mean for you? You focus on the parts you need, and the rest of the things it's not important for you, so you just use island and the magic happens for you. It's still a bit easy. Let us suppose we are interested only in the methods in a class. So we do a bit more things. Okay, let's say it starts with a class, a parser, this standard, then there is identifier, and it's followed by the end class. Do you know what happens now? First of all, I found 3 methods, the draw, the X, and the main method. Now I said I'm interested only in the methods within the class. I'm not interested in anything else. And what happens? I have only 2 methods. This island thingy, it takes care about the context. I know I am here, you're not interested in this thing, so it's actually I don't think you can do this in the standard island parsing, things like this, so it's a added value. But let's say we are interested in a bit more things. I prepared this file. This file is actually the same string, but in this file indentation matters. The method X is not aligned with the rest of the file, and let us suppose for this demo that we just want to have the methods that are properly aligned in a class. So we have to update the grammar a bit to provide some information about indentation, and it's again very easy. I just say, okay, class is followed by indent, and the dedent is in the end. And I'm actually interested only in aligned methods. So I updated my grammar again. And if I inspect the unaligned file, the result is only 1 method, only the draw that is aligned properly with the indent. If you inspect the other source that has both methods aligned, both methods are aligned. So that's my message. We have an extension for indentation thing, and we have an extension for skipping the parts you are not interested. That's all. If you have any questions. Yeah, that's your suggestion. Yeah, it's on top of my list actually. It would be interesting. Okay. I will consider that. Thank you. I agree. If I can handle this, I will be. No questions?
Can you hear me? Oh, very good. So first of all, who knows about this Small Dromeda project? Okay, not a lot. This is very good. So I want to share with you some fun stuff, right? Let's be short. You can call me Uko. I'm a PhD student in Lugano, and well, I'm doing really cool stuff. I will talk about that tomorrow before lunch break in the other room. But this is the thing that I was doing half of a year ago. And the main idea was that I took a Smalltalk hub and I tried to make some connections between developers based on how they co-contribute to projects. And this looked like a galaxy, so I called it Small Dromeda. So first of all, there is a cool video how it's being aligned. So let's look at it. And you can see some names there. Maybe you know these people. So the larger font means that they collaborate with more developers than other ones. But yeah, it aligns itself, and then in the end you get something like this. And let's look at this picture. So first of all, what you notice is that in the center you have Stefan Dukas, because he's like center of a galaxy holding everyone together. This is amazing. And I really tried to align this a lot of times, and he is always in the center. You know, force base layout. And now next thing is on the right side. You have Air Mode team who develops Faro at most. And then at the bottom you have Moose team who a bit collaborates with Air Mode. And then you have Seaside. No, you don't have Seaside yet. You have probably Chile. I don't know because I just Googled people names, and then you have Chile that are connected to Moose. And then you have Seaside at last, who are connected to the other people through Lucas Rengli. It's really amazing. There is this, this point is Lucas Rengli, and he's mainly the bridge to the other developers. And then there are some Seaside add-ons who are just clustered at the side. And what was fun, I was showing similar slides in Air Mode near Christmas. So I had this idea that at top we have Ghosts of Christmas Past, because these were mostly people who were working on Faro 1.0, and then they didn't work on anything else. And there is, for example, Steph's account who is just SD, or Stefan Dukas uncapitalized, and he only committed to Faro 1.0 and not to anything else. But let's look at something interesting. There are such things as constellations. So people who work with each other more than with anyone else. So there is Clara constellation. I don't know who she is, but it was interesting because you have some girl connected to other people and then connected to Esteban, and then you can look up her on Facebook and Google+. And she has also Esteban in her friends. So this thing works, right? And then you have, for example, Stefan Mar constellation. But when you look really close at top right corner, there is a tiny little thing that I call Five Guys constellation. Because these are 5 guys who work only with each other and not with anyone else. And there are other funny things because people commit under different names. So there is this HJO Sausage. He is a really nice developer called Hwajonol, I think, if I pronounce it correctly, and he commits just with 2 names really often and really a lot, and so it's like one sausage somewhere there. And then there is like a Bernard constellation, again showing like one main guy collaborating with some other satellites. Battery. And then there is a Nico constellation where was Nicolas Peton. And also among people who contribute with the, let's say, main developers, there are also some constellations. So there is a Serge Stingwich from a university in Paris, and he collaborates with other people, but there is visible constellation, so there is a group of people who work together, right? And sadly, you cannot see much here, but you can go on this website, and you can browse it as Google Maps, and yes, it's fun. And also, in this version, I have already merged all the usernames, so you don't have these sausages and 3 steps, like old stuff and new one. So yeah, that's our fun open source community where everything is awesome. Yeah. Thank you. Any questions?
Is it real time, or do you generate it?
No. I just had the dump, and then I try to do something. But visualizations are done in an app called Gephi, which is written in Java, and it's really good for highly connected graphs. And I have exporter for